Okay, in this video I'm going to do an example problem with a simple loss budgeting example. And the idea here is that I've got a given loss, I've got a given input power, and it asks me to find the output power. Okay, so we have P in on sort of a decibel scale here. And with loss budgeting, I make a vertical decibel scale, P out, and here's the loss. And when everybody's in decibel units, it's as simple as P out is P in minus L. And I didn't put decibel subscripts on all of these variables, but it's right next to the picture where it's labeled as decibels, and when you see this equation you should know that it's decibel units, because we're just subtracting the loss from the power to get the output power. In any case, we can do this problem, and it asks you to do the problem both in decibel units and in linear units, where we have the powers are in milliwatts and the loss is a ratio. Okay? These are the same equation, where one of them has decibel units and the other one is linear units. So this problem asks you to do it both ways, basically. What is the loss ratio? The loss ratio is 10 to the loss in dB divided by 10, and it's 10 to the 33 tenths. And if I plug that onto my calculator, 10 raised to the 3.3 power is 1.99 times 10 to the third, or 1995. I'm going to round that up to 2000. Okay? And I realize I need to put a minus sign here, and I'm supposed to get 1/2000th, because the loss is supposed to be a very small number. Okay, and this comes directly from the equations that I've given you all along. Okay, it's very easy to forget that minus sign, but if you get a loss which is a big number, then you've forgotten the minus sign. Now, the power input is plus 6 dBm. What is the output power? P out in dBm is P in dBm minus the loss in dB, which is 6 plus 6 minus 33, which is minus 27 dBm. And if I can make a better 7 than that, I'll be happy. Okay, that's really how easy this loss budgeting problem is when you're in all decibel units. But now let's do the whole problem using this loss ratio by first converting both powers to milliwatts and then taking their ratio and verifying that it's 1/2000. Okay, so if I calculate the milliwatt units for the output power, P out, it's 10 raised to the P out in dB units over 10, and so it's 10 raised to the minus 27 tenths, or 10 to the minus 2.7. 10 raised to the, there's a minus sign here, 2.7 is 1.99 times 10 to the minus 3, or let's call it 2 times 10 to the minus 3. And this is going to be in milliwatts. Okay, you could write this as 2 microwatts. Micros are 1,000 times smaller than milli. Okay, so let's convert the input power to milliwatts. P in is 10 raised to the P in dBm over 10, and it is 10 to the input power is plus 6 tenths. And 10 to the 0.6 power, 10 raised to 0.6, is 3.98, or 4, let's call that 4 milliwatts. Okay. Finally, we're going to take the ratio of these two values, P out over P in, and we're going to get 2 times 10 to the minus third milliwatts over 4 milliwatts. The 2/4 is a 0.5, and so I have 0.5 times 10 to the minus third. And if it were 1 times 10 to the minus third, that would be 1,000th, but it is half of that, so it is 1/2000th. And that agrees with what we had up above. Okay, so this is an example where we've done the simple loss budget two different ways, and it works out. And you should be able to do a problem like this to show your understanding of decimal units. Hope that helps.